Chapter 9, Lesson 4, Simulations. Welcome back, everybody. Hopefully you guys are doing okay. So with this problem here, let me clear the screen. There we go. So we are identifying outcomes in a random number table used to simulate a simple event. So I'm going to go through this section here, try to make sense of it. Okay, so the winners of a carnival game draw a ticket from a box to determine their prize. Each winner draws a ticket and places it back into the box before the next draw. Every winner has a 19% chance of getting a pencil pouch, so this is going to be important, a 34% chance of getting a backpack, and a 47% chance of getting a gumball. Okay, so the game operator wants to simulate what could happen for the next 10 winners. So for each winner, she generates a random whole number from 1 to 100. So you're going to spin or select a number, and if you get 1 through 19, you're going to get a pencil of those numbers. In this here, 1 through 19, that's going to represent 19% chance. And from the numbers from 20 to 53, you're going to get a backpack. So that's 34% of the time. And you can see that from 54 to 100, that is going to be 47% of the time. So now, winner number one, did they spin this, you guys, or did they draw a ticket? It looks like they draw a ticket 1 through 100. Let me clean this up a little bit. And this is where it tells you what the person got. So the winner number one, when they drew a ticket, their ticket was number 22. And winner number 8, their ticket was a 93. So winner number 8, if they pulled the 93, that's going to be down in this here. So winner 8 got themselves a gumball. So let's take a peek. I can't see the rest of the screen here, you guys, so I'm going to scroll a little bit and then we'll answer the questions. So for part A, winner number 7, that's what they want to know. So in the simulation, which prize did each winner get? So winner number 7, they picked a 3. And if you pick a 3, 1 through 19 tells you that you're going to get a pencil pouch. So right down here in this section, you are going to select pencil pouch. Okay, I will just say PP for that. All right, let's see what winner number 8 is. We actually, we just did number 8 by chance. Okay, so winner number 8, they pulled a 93, and if you pull a 93, you're going to get a gumball. So I will say GB for gumball there. And then winner number 9, they've got a 34. So look up there and tell me what you guys think they would get if they got a 34. Yes, 34 is in this area, so they would have themselves a backpack. Okay, let's move on down to the next problem. Okay, what do we got here? Using a random number table to simulate a simple event. I'm going to start right here, you guys. The winners of a carnival game draw a ticket from a box to determine their prize. Each winner draws a ticket and places it back into the box before the next draw. Every winner has a 16% chance of getting candy corn, a 30% chance of getting a t-shirt, and a 54% chance of getting a keychain. The game operator wants to simulate what could happen for the next 10 winners. So for each winner, he generates a random number from 1 to 100. What is the range of values that the game operator can use to represent a winner getting a keychain? Okay, so 54% of the time, they're going to get a keychain. So what we could do is we could say every random number between 1 and 50 would be a 50% chance, right, you guys? But we don't want a 50% chance. We want a 54% chance. So every number from 1 to 54 could represent a winner getting a keychain. All right, let's look at part B now. So these are the results of what happened. So winner number 1 rolled a 41, number 2 got a 58. Let's look at a question down here. Using your answer to part A, so part A we said 1 through 54. Find the percentage of the 10 simulated winners who got a keychain. So who got a keychain, you guys? The only people that got a keychain are the people that ended up between a 1 and a 54. So this person got a keychain, and this person got a keychain, and this person here got a keychain, and this person got a keychain. Winner number 7 got a keychain. Winner number 8 got a keychain. Winner number 9 got a keychain, and winner number 10 got a keychain. Okay, those are all the ones that spun or pulled a ticket between 1 and 54. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 people, or 8 winners out of 10 winners got a keychain. 8 out of 10 is the same as 80%. So our answer down here is going to be 80%. All right, I think we have one more here, you guys, and then we're going to be done with 9-4. All right, last one here, you guys. Generating a random number table with technology to simulate a simple event. So a jar has 50 jelly beans, you guys. 9 of them are blue, 6 maroon, 21 green, and 14 of them are orange. So make a percentage bar graph for the jelly beans in the jar. Well, to me, what we currently have is a 25% and a 25%, 25 and 25. Well, 14 out of 50 is not 25%, right, you guys? 9 out of 50 is not 25%. So what we're going to have to do is we're going to figure out those percentages, and then after we figure out the percentages, we're just going to go ahead and adjust our bar graph, and we're going to adjust our bar graph with that the little slider right there. Okay, so let's do 9 out of 50 first, you guys. Those are the blue ones. So 9 out of 50 is going to give me 9 divided by 50. Okay, we'll put the 9 in the calculator first, or if you're going to write this as a fraction, just do 9 over 50. And that's going to give us 0.18 or 18%. So what we're going to want to do is we're going to take this slider here and we're going to move it until this section here is at an 18%. So now we want to go ahead and do the same thing with the maroon, and the maroon is going to be 6 divided by 50, and that's going to give me 12%. So let's go ahead and slide this over here. So that's going to give me 12%. We're going to do the exact same thing with the green jelly beans. Now that's 25 divided by 50. So hopefully you guys know right off the top of your head. Oops, did I say 25? I did, so I kind of messed up there. So it's going to be 21. So we'll do 21 divided by 50. And 21 divided by 50 is going to give me 42%. Okay, so this section here needs to be 42%. And then lastly, we have the orange, and the orange is going to be 14 divided by 50, and that's going to give me 28 or 0.28. And 0.28 is the same thing as 28%. Okay, that's it for part A. Let's go ahead and take a look at part B now. So with this one here, you guys, we've got a jelly bean is drawn at random from the jar and then put back in the jar. So in our simulation, we're going to click on run or press run, and we're going to have it simulate 1,000 tries based on this percent graph that we made up here. Okay, so if we have 1,000 tries and we've got 18%, we can just do 1,000 times 0.18. Okay, or you can do 0.18 because it's 18% of 1,000. Either way, it's going to work for you. Okay, so you can do that in your head, and if you can't do that in your head, yeah, no, you guys should be able to do that in your head. Okay, so that's going to give you 180. So we would have, in our simulation, we would get 180 blue jelly beans. Now we're going to do the exact same thing with 12. So we'll do 0.12, so 0.12, whoops, 0.12, let's try that, times 1,000, and that's going to go ahead and give me 120. Let's go ahead and do 0.42 times 1,000, that's going to give me 420. It's getting kind of tight in here, you guys. 420. Let me clean this. Nah, I can't clean it up here, you guys, just because I don't want to lose that data up there. So let me rewrite this. So the blue ones, we've got 180. The maroon ones, we have 120. The green ones, we have 420. And the orange ones, we're going to do 0.28 times 1,000. So that's going to give me 280. And then the one thing that you guys want to do is you want to make sure that those numbers there, your 280, your 420, plus your 120, and your 180, you want to make sure that they add up to 1,000, because that's what that's how many samples we have here. So we've got 1,000. So, and they do. So that means we're okay. So I'm going to switch colors here, and we're going to go ahead and do the last part of this. So when a jelly bean is drawn, it's most likely to be what color? So it's definitely most likely to be green. So down here we would choose most likely to be green, okay? And in the simulation, this color jelly bean was drawn in what percentage? Okay, so in what percentage, you guys? Well, 42% of the time, right? We already said that the green ones were going to be 42%. You can also figure that out because you can do 420 divided by 1,000. So down here, we've got 420. Okay? That's it for the section. Good luck on your homework.